Hi there, Mr. Sutton with the first of 2 lessons on ellipses. In this one, we're going to figure out how to find the center, vertices, and foci of an ellipse, and to use that information to graph it. For the real-life application, whispering chambers are a great example of an ellipse in action. We're going to start right off with why I think ellipses are cool. So this is the Statuary Hall in the Capitol building in DC. It has an elliptical shape. If you look at it kind of a cross-section from the side, it's the top half of an ellipse. In it, there's 2 places on opposite sides of the room, like here and here, where 2 people whispering can hear each other, just as if they were standing right next to each other. Those 2 places we're going to see are called the foci of the ellipse. More on that in just a moment. Let's talk about some ellipse terminology now. Like a circle, an ellipse has a center, which we'll call h comma k, based on the formula we're going to see later. Unlike a circle, an ellipse also has 2 foci. So what are these foci? Well, the sum of the distances from the ellipse to each focus is constant. So if you have your 2 foci in here, and you were to put a string around these and kind of put a pencil in the string and move it as far as you could go in every direction, that total distance would always be the same if you add up these 2 distances. So that's how we actually could draw an ellipse if we wanted to. It's not how we're going to, but if we had a string, we could draw it like that. So let's take a look at some of the other measurements here. The major axis, that is the longer direction, which is either going to be an x-axis or a y-axis kind of direction. And the vertices, those are the endpoints of the major axis. So in this ellipse, where we have a major axis going sideways, x major axis, the vertices are on the far left and the far right. Now, we can also talk about the distance between the vertices and the center. We call that distance the a value. You could think of this as a big radius. Now, how about the other end? Well, the minor axis, that's our shorter direction. The endpoints of the minor axis are called the covertices. And if you want to talk about the distance from the center to each covertex, that's called the b value of the ellipse. You could think of the b value as the smaller radius. So the b value, for example, would be from here to here. We can also talk about the distance from the center to the foci. We'll call that the c value of the ellipse. And you notice that the foci and the vertices are on the major axis, whereas the covertices are not. But now everything is going to change, everything except the center, if the major axis changes. So if we had major axis y instead of major axis x, like we do now, well, now the foci and vertices are vertical values instead of horizontal values, and now the covertices are left-right. Let's talk about ellipse equations now. The correct equation to use is actually going to depend on the major axis. There's 2 different ellipse equations, and the thing that these have in common is that the a squared is always going to go below the letter of the major axis. So let's check this out. Let's check out the major axis x first. This is your left-right ellipse. So for this one, the equation is going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. So it's kind of like a circle with the x minus h squared and the y minus k squared, but instead of some number other than 1 over here, we're actually always going to have a 1 that these things equal. And instead of having the radius decided over here on the right, we're going to have a big radius and a small radius decided over here on the left side underneath these fractions. Major axis y is going to look very similar, except now we're going to have the x's over b squared and y's over a squared. Again, a squared is always going to go below the letter of the major axis. Now, the good news is that there's a relationship between a, b, and c that's the same for either type of ellipse. So for both types, b squared, the smaller radius squared, is going to be a squared minus c squared. And if you want to find c squared, you can just shift things around here and write c squared equals a squared minus b squared. So if you're wondering, which order do I put these letters in, always remember this. A is always going to be the biggest out of the 3 values you have here. So whatever you're doing, you need to be subtracting something from a squared to get whatever value you're looking for. Eventually, we're going to be able to graph an ellipse based on the equation. We're not quite there yet, though. Let's find some bits and pieces first, and then we'll move up to graphing the whole thing. Let's start with the vertices. To find the vertices, you first need to know where the center of the ellipse is, because the vertices are however much A is away from the center. So this is going to be, for this one, 3, comma 6. It's just like finding the center of a circle. You just take whatever zeroes out each of these squared parentheses for x and y. So 3, comma 6. And then we know that the vertices are a certain distance away from the center, but which direction? That's going to depend on the major axis. They're either going to be left, right of the center or up, down from the center. But they're in line with it in one way or another. So we have to next identify the major axis. And again, this is going to be the one for ellipses that has a larger denominator. So looking over here, the larger denominator is under the y values. So we're going to say our major axis is y for this one. This is an up-down ellipse. So we know that when we go ahead and find the vertices, they're going to be above and below the center, because the vertices are always on the major axis. They are the endpoints of the major axis. So we need to figure out the exact distance that they are from the center. To do this, we're going to square root that larger denominator to get the a value. Normally the larger denominator is a squared, so again, square rooting that gives us a. So that gives us an a value then of 5. So whatever a is, you just have to add and subtract that to the major axis coordinate of the center. The major axis coordinate in this case is y, so we need to do plus or minus 5 to the y value of the center. So our vertices are going to be at the x value 3, but to find the y values, we have to add 5 and subtract 5 from 6. So that's going to be 3, comma 1 and 3, comma 11. Next up, we're going to see how to find the foci or foci of an ellipse based on an equation. So finding these is kind of like finding the vertices, at least in the way we begin. We still need to find the center. So here, that's going to be 12, comma negative 5. And what do you think the major axis of this ellipse is? Yeah, it's x, because now we have a larger denominator under the x's. So what do we do with this? We need to find a c value now. C is the distance from the center to the foci. And just like the vertices, the foci are on the major axis. So we're going to be adding and subtracting something this time to the x value of the center. To find the c value, you have to use this formula here, c squared equals a squared minus b squared, which basically amounts to subtracting your denominators and then square rooting. So that's going to be 31 minus 6. We always do bigger minus smaller, because a is always bigger than the b value. So 31 minus 6, that's 25. And the square root of 25 now, because we only have c squared at this point, the square root of that is going to be 5. So we have to add and subtract 5 then to the x value this time around. If this had been major axis y, we would have done this to the y value again. But since it's x, we do it to the x value. So we have 12 plus or minus 5, comma negative 5. The y value is not going to change. But for x values, we now have 7 and 17 for the foci. And just like I did with the vertices, I'm going to label these as F1 and F2 instead of V1 and V2. So our first focus, 7, comma negative 5. Second focus, we can say, is 17, comma negative 5. Okay, now we're going to put it all together and sketch an ellipse. We'll do this one together, and then you can try the next one on your own. Let's start by finding the center. So what's the center of this ellipse? Oh, negative 2, comma 0. Awesome. Let's put that on here. Next, we're going to find the a value and use that to draw the vertices. Now, before we even find a, let's figure out the major axis here. That's going to be y. So we're going to take the square root of the thing that's under y, because that's the larger denominator. Square root of that is going to give us an a value of 3. Since it's major axis y, that means we need to go 3 up and 3 down from our center. So 3 up and 3 down. Next, because we need a little bit more to graph an ellipse, we're going to find the b value, which we haven't done up to this point. And we're going to use that to draw the covertices. Well, that's just going to be the square root of the smaller denominator. So the square root of 4 in this case, which is 2. So that's 2 to the left and 2 to the right. Next, we're going to find the c value and use that to draw the foci. And you might need to estimate this. So that's going to again be the subtract the denominators and square root a squared minus b squared. So that's 9 minus 4, which is 5. So we need the square root of 5. To actually graph that, I'm going to need to estimate it. That comes out to about 2.2. So I'm going about 2.2 in the direction of the major axis, that's y, so up, down. So up about 2.2 and down about 2.2. Again, just an estimate. Finally, I'm going to draw the ellipse through the vertices and co-vertices. So I'll start up here and then I'll just connect the dots in an elliptical fashion. And there we have it. Now you might be saying, hold on a sec, did I really need those foci in order to connect those dots? No, you didn't. But typically you are required to draw the foci in there as an extra little feature. So get used to doing it. We're going to do one more example with sketching. Pause the video and see if you can graph this one all on your own. Then we'll bring it back together. All right, so we got our center first. That would be 0, 1. So that'll be right here. Major axis x for this one, because our x values have the larger denominator. So the a value is going to be the square root of 16, which is 4. Since it's major axis x, that means we're going 4 to the left and 4 to the right. For our co-vertices, that's the square root of the smaller denominator of 9. So that'll be 3. So 3 up, 3 down. For the foci, that'll be square root of 16 minus 9. So square root of 7. And what's that? Calculator says that comes out to about 2.6. So that's going to be 2.6 to the left and 2.6 to the right. And connect the dots. Woo, there we go. So that's it for graphing ellipses. As you can see, there's a lot of different things with ellipses to keep track of. However, you're doing the same things pretty much every time. So as long as you practice and get some practice with both major axis X and major axis Y, you should be fine. Until next time, this is Mr. Sutton signing off.